What we've got here, the upper portion of the crane boom, I guess, yes, crane consists of a jib AB. Where's AB? Yeah, that's a jib AB. This one is AB, okay? Which is supported by the pin at A. So I've got a pin at A here. The line BC, where's BC? This is BC, that's a cable, okay? So we've got BC also. I always know cable is always in push. The backstay CD, where is CD? Yes, there's another cable here, that's here. Each cable being separately attached to the mast at C. So both cable are separately. There's no, so saying there's no pulley here. Basically, they are separately connected to a pole at C. If the load F is supported by the hoist line, so that's here, if F is supported, which passes over the pulley B. Oh, I've got a pulley here. That's my pulley B. Determine the magnitude of the resultant force the pin exerts on the jib at A for equilibrium. So we need to find the reaction force at A. So it's a pin, so I definitely know there are two reaction forces. There's no reaction moment because it's a pin. We need to find the tension in the cable BC. So we need to find this. I will write it in this way. I will not write in this way because I know cable is always in pull, as you know that. So that I need to find. And the tension T in the hoist line. So tension T in the hoist line. So that's here, this one. Also hoist line. That's I need to find the tension here. Neglect the weight of the jib. The pulley at B has a radius R. Interesting. So the radius here is R. The pulley has got a radius R. So the very first thing that we need to find is easy if we start from the pulley. So that we find the tension. So let's draw the free body diagram of, sorry, the tension is not here. The tension is here. It is the same thing because you got another pulley here and another pulley here. So the tension T here, sorry, come on. The tension T here is the same as the tension T there. So let's draw the free body diagram of the pulley first. So I've got a pulley and it's pin connected at the center. So I've got my pulley here, which is pin connected at the center. There's no reaction moment, so I've got reaction force. So I would say Rx and Ry. That's the reaction. And then I've got the force acting downward, that's F, which is the same acting here. So even if you look at this diagram here, can you figure out what is the tension in the cable?
Sir, 5 kilonewtons.
That's the tension in the cable, same tension going everywhere. The force F downward is how much? This force is 5 kilonewton. So what is the tension in the cable?
It's the same.
It's the same, yes. So same F goes here. Okay. So you had a pulley connected at the center. You had your Rx and you had your Ry. You had a force F and you had a tension T here. It's a frictionless pulley, so same F, T and F are same, so F equals T. So we know that the tension in the cable is F, which is equal to 5 kilonewton. Now I'm still working on this diagram here, and I do sum of all the forces along x along y. So Fx, Rx definitely is equal to this, and Ry is definitely equal to this. Is that clear?
Yes, sir.
So reaction forces, we know the reaction forces on the pin for the jib. Now, now we're looking at the jib, AB. So same forces on the pin, but opposite direction appear on the jib. Is that clear? The two forces, that's the pin. I've got my reaction force F and F. The same pin is here. So I've got the same forces, but in opposite direction. Can you see that?
Yes, sir.
Okay. So free-body diagram of the jib. I've got pin connected at A. So I've got a jib. That's my jib. Let me make it here. That's my jib. This is A and this is B. At B, I found out the pin forces. So I would say this is my F reaction force, and this is also F. At point B, I've got a cable, so I've got another active force here, which I need to find. And at A, I've got active reactive forces at A. So I've got 1, 2, 3, 4, 5 forces acting on the jib. Is this clear to everyone? This one.
Yes, sir.
Can I ask you the question, why I'm not showing the cable force? This one. Why I'm not showing this cable force on the free body diagram?
Because it's not exactly acting on the jib.
Yes, it's not acting on the jib, it's acting on the pulley, and its reactive force is on the pin. And I have got my pin reactive active forces here. That's why. So remember, if I have to draw the free body diagram for any one part, I just draw that part, and all the forces acting on that part only. Okay, so I've got this free body diagram, which is the same as this one. So I'll drop it off now. And you apply your equation of equilibrium, you will get all your forces out. You won't do the calculation, you know how to do the calculation now. So is that clear to everyone?
Sir?
Yes?
Sir, considering the pulley only, so
Yes.
why are both the reaction forces F and F?
Okay, I'll go back. So let's look at the diagram here. I'm looking at this diagram. So I want to draw the free body diagram of the pulley. So I will draw a pulley. And it's been connected at the center. Okay. Let's see the active forces on the pulley. So the pulley has got a cable here that's acting downward, and there's a force of 5 kilonewton on it. And the same cable is going here. So that's another force of, because it's a frictionless pulley, so you know that whatever tension is here, the same tension will be here. So 5 kilonewton. Do you agree with me?
Yes, sir.
Okay, so now it's pin connected. So it's a 2D. So 2D, you've got three reaction forces. You got Fx, you got Fy, and you got moment. Okay? Because it's a frictionless pulley, it's pin connected, so it is free to rotate, so this will not come in. So there are two reaction forces for a pin. It's an Fx and an Fy. Now I'll do sum of all the forces along X, which means Fx is equal to sum of all forces equals 0. So Fx minus 5 kilonewton equals 0. This 5 kilonewton is this one, opposite direction, so you got a negative sign there. So therefore your Fx comes out to be 5 kilonewton. In the very similar fashion, you get your Fy out. Is that clear now?
Yes, sir.